Welcome back. We'll solve few more problems in permutations and then we'll move to combinations. So this can just take these questions as practice questions. Okay. So in how many ways can the letters of the word hunter be arranged such that the word does not start with H? Okay. So we have hunter. How many characters? 1, 2, 3, 4, 5, 6. What they are saying, this position should not contain H. Okay, in how many ways you can do it? So UNTER, okay, 5. So you can place 5 letters here in 5, any 5. So it can be done in 5 ways. Then rest left is 1, 2, 3, 4, 5. Okay, 5. How many left? If I place any one of these words, so again I'll be left with 5. So it is 5p5 or 5 into 5 factorial. That is, we'll get 600. Next, how many 4-digit numbers greater than 3000 can be formed using digit 2, 3, 4, 5, 6. So the number should be greater than 3000. Okay, that is a restriction. So what are the digits given? 2, 3, 4, 5, 6. So you have to form a 4-digit number. Greater than 3000 means what? So you can place, you cannot place 2, right? If you place 2, it starts with 2. That means it is less than 3000. Okay, so let us say I will place 3, 4, 5 or 6 here. That is, I can place in 4 ways here into, I'm left with what now? 2 and any of the 3 digits left here. Okay, 1 is already used here in this position. So now I am left with how many? 4 digits. So 4 P, what is, how many I have to fill? 3, right? 4p3. So 4 into 4p3 is 96. Next, how many ways can the letters of the word committee can be arranged such that all T's are together? So let us put this T together. Okay, consider it as one letter. Then you have COMMIEE. So it will be 1, 2, 3, 4, 5, 6, 7, 8. So this will be equal to 8 factorial ways divided by T. M is repeated and E is repeated. So 2 factorial into 2 factorial, and then this T can be arranged in 2 factorial ways divided by 2 because it's indistinguishable. So this will come to 10080. Okay. Next, how many 4-digit numbers can be formed? 1, 2, 3, 4 using digits 1 to 9. Okay, 5 appears at least once. So at least once, when you see at least once, what you have to do? It's subtraction problem, right? So first you find out total ways. So total ways equal to, so how many digits are there? 9 digits are there. Okay, so I have to form a 4-digit number. So choose or select 4 from 9 digits. So what will be this value? 9p4 equal to 3024. Okay, then appears at least once means, let us first calculate. It doesn't appear. No 5 appear. How many ways we can do it? So 1, 2, 3, 4, 5. Okay, now this can be, how many digits are there? So total 9 digits are there. Okay, 9 digits. That 9 digits, pi should not be there. Okay, so we will be left with 8 digits, and then we will be left with 7, 6 and 5, right? Or you can just say it is 8p4. So this will be equal to 1680. So you subtract these two values, we will get at least 1 5. 1,5 is equal to this total ways minus 1,680. This will be equal to 1,344. Okay. Next, in how many ways can 5 boys and 3 girls can be seated in a row such that all girls sit together? Okay, so we'll create a group G1, G2, G3. There are 3 girls, they all have to be together, and you have 5 boys. Okay, so now this is 1, 2, 3, 4, 5, 6. So 6 factorial. Okay, and we are not going to divide because all boys are different and all girls are different. Into these 3 girls can be seated in any permutation, right? G1, G2, G3, or G2, G1, G3, like that. So it will be 3 factorial. 6 factorial into 3 factorial ways. So it will be 4320. Next, how many arrangements of the word balloon can be made such that L's are not together? Both L's are not together. Okay, so how will you find? So you can find it using subtraction, or you can do it using division. So whichever you feel comfortable, you can do it. So let us do it in the other way. So let us form the configuration. Okay, what they are saying now, L's are not together. That means what? So B can be there, then A, then O, then O, then N, and then so the L can be anywhere here. 2 L's can be anywhere here. Now this can be arranged in how many ways? 1, 2, 3, 4, 5. So 5 factorial ways divided by the O is repeated, so divided by 2 factorial ways. And then how many slots are there? 1, 2, 3, 4, 5, 6. So out of 6, I have to choose 2 L's into, see, these 2 L's are same. So 2 factorial ways I can arrange them, but since they are indistinguishable, divide them. So this will get you 900. Okay, how you can solve, or else you can go for the subtraction rule. Okay, you find out total combinations and then you find out they are together. Okay, that is also one way. Now, how many 3-digit even numbers can be formed using digits 2, 3, 4, 5, 6 with no digit repeated? So 1, 2, 3 digits. So 2, 4, or 6 can occur here in the last this place because it's even number. So now if 1 occurs, so this can be done in how many ways? 3 ways, right? Into, now there are left out 2 digits. If I take 1 out of this, 2 will be left. Okay, 2 will be left. Now how many odd digits are there? 2. Okay, 4. So I can do it in 4p 2 ways. So this comes out to be 36. Next, from the word statistics, how many distinct arrangements are there where all S are together? So same thing again, all S. How many S? 3 S are there. Then I have T, A, T, I, T, I, C. Okay, so this is one group. 1, 2, 3, 4, 5, 6, 7, 8. So this will be equal to 8 factorial divided by, this is repeated, right? 1, 2, 3 into, again I is repeated, 1, 2, 2 factorial into, this S's can be formed in 3 factorial, but they are same, again divided by 3 factorial. So the answer will be 3360. Next, how many ways can 6 people be seated in a row such that A and B have exactly 1 person between them? Okay, in the circular permutation, similar question we have solved. Okay, but it is not a circular permutation, it is a linear permutation they have given. So they are saying that there are 6 persons. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. These are the places. Now, we have to find out how many ways 6 people will be seated such that A and B are exactly one person. Now, suppose say that if I place A here, then B should be here because exactly one person in between A and B. Now, similarly, if A is here, then B has to be here. Okay. If A is here, then B has to be here. If A is here, then B has to be here. So what are the possible combination? 1, if A is at 1, okay, the B has to be at 3. If A is at 2, B has to be at 4. If A is at 3, B has to be at 5. B is at 4, B has to be at 6. Now we will stop here because if A is at 5, I cannot be at 1. B cannot be at 1 because it's not a circular permutation. So that is the difference here. So this can be done in what? B and can be placed in 4 ways. Next, 4 into. Next, remaining how many slots? 4 slots. So 4 slot can be permuted in 4 factorial ways. Okay. So this will be 4 into 4 factorial. So it comes out to be 192. Okay. So don't confuse the circular permutation and linear permutation. Okay. Next, the last question. How many ways can 5 identical red balls? The identical, all are same. You cannot differentiate between 5 different red balls. There are no different balls. All are same. And 4 green balls. How many ways this can be arranged in a row? Never in most times when you practice more questions and combinations and all, you may be confused because, or you may be like treating like when you see a balls and green color balls or white color balls, red, black color balls, that kind of questions. You are in the thinking mode of it is a combination problem, but they are saying it is arranged. Okay, that's why I taken this question. So total 9 balls are there. They can be arranged in 9 factorial ways. Now 5 red balls means 5 indistinguishable divided by 5. This divided by 4 green balls. So totally we will get 126. I think this is the answer. So, so this is about all permutation problems you have solved. Then from the next lecture, we will move to the combination problems. Okay. So please subscribe, share with your friends. Okay, anyone who are interested to learn. Okay, please do subscribe. Thank you.